Hello everyone, and welcome back to another video. Um, Today I'm just gonna do a little bit on double linked lists because with my previous video, single linked list, I think I covered most of the basic already. So we're just gonna go ahead and go do some double, and after that I'll probably post some videos on leak code probably. Okay, so a double linked list is better in certain situations than a single linked list since it provides like more flexibility and efficiency. But then there's also like there's basically pros and cons. Now the pro is compared to a single linked list, you can travel backwards. So with a single linked list, you start from the head and then you move obviously to the first node and then move to the second node to the third, and then it goes into null, right? But with that's a single linked list, but that means you can't really go back and forth in your node. Now with a double linked list, you can have another pointer that points backward, so it allows you to travel back and forth basically. If you want to delete the last node, it's O1 because you use a pointer called tail. So there's no need to like go through the whole list. You can just delete the last node instantly. You can also do like insert before a node. Same thing. It's simple because you have like a previous pointer, which is basically the pointer that's pointing back. So you can do things like that. It's very easy, like insertion both before and after basically. Now the bad part is that it takes more memory because it has like an extra pointer. It's slightly more complex to implement and maintain, and and it's not necessarily if you only need like one directional traversal. So basically, if it's just one direction, single, two directions, double, right? So, and some example use cases, right, would be like, let's say you're doing a browser history navigation, so it has like a forward and a backward button. If you're playing like a music or video playlist, you can skip forward, skip backward. Other things like redo and undo, those are pretty cool too, right? So double linked list would be pretty useful in certain situations like that. And so the best way is, I think I should also write down the definition, right? So a double linked list is a type of linked list where each node has three parts. Okay? I'm gonna move this down a little bit real quick. So the first part is data. Data stores actual value. Actual value. Sorry for my handwriting. We have a next, which points the next node. I mean, you already kind of seen that before. And then there's the third one, which is previous points previous node. I don't feel like writing the whole thing, but I'm just gonna write it anyway. Okay, so with the next and prev, it allows you to travel back and forth basically. And I mean, I kind of wrote it down, but I'm gonna write it a little bit clearer. So with a single linked list, I'm just gonna write single LL. We have the head, and it goes to the first node, points to the second, points to the third node, and then null. Correct? Now with a double, so I'm gonna write double LL. You have a head, and it goes to the first node, second, third, and then null. Oops. Like that. But you can go back, and then this will also point to null actually. So 1, 2, 3, something like that. And then obviously there's like a value inside, you know what I mean? And and then there's like another one which is like circular, but I'll go with that one in a much later. So in a way where I think I should just write it in my VS Code, or I can just write it down. So basic structure, right? You have class, node, we have the int data, then we have node for next and prev or previous. So inside the node data, there should be an int data right here. Okay. Then you should have this dot data equals data. This dot next equals null. This dot prev equals null. Something like that. That just basically creates like, I mean, I'm not really creating anything because everything is pointing at null anyway. But okay, maybe it's better if I type this on a code. So I'm gonna switch to VS Code real quick. Alright, so basically we're back here again. The pain. But let me get ready first. Okay. Alright, so basically in back here, we're just gonna create a new section, right? And we're gonna call it double linked list. Right here, we're gonna have a static class. We're gonna call it double linked list. We're gonna have a static class. We're gonna call it node. Let's call it D node. Stands for double node. Or okay, that's a really bad naming, but whatever. We're gonna have int data. And it feels weird to type, but who cares, actually. Okay, this feels really weird to type. Maybe I should change the name. Nah, it's too late now. I'm gonna create exactly what I kind of wrote, like that. And then, D node equals head, D node equals tail. And what is wrong with this? Is there something wrong with this? Oh, right? Oh, not equal. Oops, there we go. Oopsies. Okay, whatever. This part, let's add. And it's gonna add to the end. So, public void add int data. The node. We're gonna have it new node equals new D node data. Okay. And then if head is equal to null, and I'm just typing this out for now. I'll explain it later, obviously. But if head equals to node, head equals tail, which also equals to new node. We can just write it like that, obviously, and just return. Okay, afterward, tail.next equals new node. And then new node.previous equals tail. And then tail equals new node. Now we're going to print. We're going to have print from head to tail. This would be called printing. This would be called print forward. We're going to have another one, but we're going to do this. Print type temp equals head. And system point out. Oh, well, let's just call it forward. While temp is not equal to null, then you basically print out, and there's no need to break the line. So print out. Actually, there's no need to do this either. So let's just do that. What we're gonna do is we're gonna print out the temp data, and plus, let's have the arrow sign. The forward and backward, basically. And then temp equals temp.next. So this way it'll print out the thing the data. Okay, that's one. Now we're gonna have print backward, which is kind of the same thing actually. Print from tail to head. Public void, we're gonna call it print backward. Boom, 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 boom. There we go. ID node temp equals tail. This time we're starting from the back. Backward. Now, same thing. While temp is not equal to no. We're gonna have the same thing print out like this. Temp dot data plus then boom, boom, boom. Boom, and then temp equals temp dot prev, which is previous. And print out. Oh shoot! There we go. No. Now, onto this let me delete this one because that's what we did last time. And we're gonna first. Let me check with this one. This one should still be the single link list, right? Yeah. Now what we're gonna do is we're gonna test the double link list. Boom, 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 and double link list. We're gonna call it D list because I like D. Oops, sorry, I didn't mean to say it like that. D list, D list maybe. No, okay. Add 20. Let's do the same thing. Let's do 30 and 40. Now that I'm done, we're gonna print out the D list. Let's print out the forward first. And the D list. Print out backward. Perfect. Now it's gonna print forward and backward. But before that, let me explain. Okay, so so with the double linked list, it will be a two-directional list with a prev or previous and next pointer, okay? So here what we have, starting from the very beginning, or actually let's go even smaller first. Let's do it this one right here. So this is what we have. Each node stores, so we have the data which stores the value. We have next, which is a pointer that's going to point to the next node, and then we have a pointer that's going to point to the previous node right here. Okay, that's what we have. Now here's so our first node would be the head, and our last node would be the tail. This makes the forward and backward like traversal possible and efficient, basically. Now, what we have are the methods, which is, so our first method is add, and this adds a node to the end, right? So by looking at it, we're going to have the if statement, which is if it's empty, meaning that the both head and tail, or I'm just going to say head in general. If if it's empty, then both head and tail becomes the new node. Okay? Otherwise, we're going to link the tail.next to a new node, and then link the new node dot previous to the current tail, and then update the tail. How should I... Okay, let me see if I can write it down in a way. So let's visualize like what I mean. So let's say what we're gonna do. Let's say like here's what it's gonna look like, right? So I have a head that has a 10, and then a 20, and then null, right? What's gonna happen is since my add is gonna add towards the end, if I'm gonna, let's say I'm gonna add a 30 into it, correct? So what we're gonna do is we're gonna run the add 30, and what's gonna happen is the tail.next, which tail is like on the 20 basically. This is where tail is. Tail.next, which is the null area, will become a new null, making it 20 pointing at 30, and then the new null prev, which is the new 30, that prev is going to point back to tail, which is going to point to 20. So that creates this, that's going to create the forward and backward, pointing to 20 pointing to 30 and 30 pointing back to 20. And then afterward, the new tail is gonna be pointing at the new node, which is 30 being the new node. So it's gonna look something like this. We're gonna have it, well, let's just keep it like this for now. Basically what we're gonna have is we're gonna point at 30, and then afterward new node.prev is gonna point back at tail, and then we're gonna change, and then on the very last part we change the tail to where 30 is, and that's it. I mean, I don't know what else can I explain in this. This is the best I can do. And then here's the part. This part should be really easy because we've already done that back in it's the same thing when you print a list on a single linked list. See, it's the same thing. You have a temp that's pointing ahead while temp is not equal to null. You print data with the arrow, and then you move temp to temp.next. And then once the while statement is done, you print out node. So the forward is basically single linked list. Backward, on the other hand, is you're just starting from tail, and then you're moving back, which is the prev. That's why it's prev and not next. Now, with this, it should print out a forward and a backward. Yep. Here's the forward, so 10, 20, 30, 40, and then null. And then here's the 40, 30, 20, 10 null. And that's just basically the basic of a double linked list. I'll probably do like one more topic on it before I do like a LeetCoder or whatever. And this video has gone way too long because I explained way too slow. All right, anyway, thanks, bye.